What is the population of India? Okay, 140 crore. Is it exactly 140 and 7 zeros? 140 crore, 0 lakh, 0,000 and 0,100? No, there is a possibility that some lakhs and some thousands are there, but when we write the population, what are we saying? 140 crore, all zeros. So observe the number. In this number, how many digits are reliable? How many digits are perfect? 1 is perfect, and that 4 may be perfect, and the next 0, it may be 141 crore, or some difference can be there, and that digits of lakhs and thousands also may change. So we are not sure about them, which means in this number, which has 10 digits actually, only 2 are reliable, only 2 are significant. So this kind of reliable digits we call significant figures. So in this number, there are 2 significant figures. So what is the significant figures and how do we count and how do we write them? Let us see today. Welcome to Physics A to Z. See. First of all, let's see the definition. What is significant figures? The definition comes like this: the number of reliable digits in a number. So we give a numerical value, let us say. In that value, how many digits are reliable? So the number of reliable digits in a numerical value is called significant figures. And why do we need it? Why do we need to find out number of significance? For example, like we said the example, in 141 crore, only 3 digits are significant. Remaining are uncertain, we don't know. So it tells us that how much accurate the data is, how much precise the value is. So indirectly the significant figures, the number of significant figures tells us the accuracy. In other words, the precision of the given data. Right? Now, how do you count how many significants are there? We have some rules to find out how many significants are there. Let us see. First one. First rule. All non-zero numbers are significant. All non-zero numbers. So for example, we have a number, let us say 2200, like something number like this. In this one, according to first rule, 2 is significant and another 2. These 2 are significant, right? And what about the remaining zeros and all? Let's see in other rules. Coming to the second rule. All zeros lying between the non-zero numbers. Between the non-zero numbers are significant. Right? So which means in this number, if you see the zeros, this one and this one, okay, these 2 zeros are lying between the zeros, between the non-zero numbers, these 2. So they are significant. So far we got 4 significant figures in this given value. And what about the remaining zeros? Let us see. Third point, about the remaining zeros, we call them trailing zeros. What is meant by trailing zeros? Trailing zeros means the zeros on the extreme right, the ending zeros of the number. So here we have 2 of them. At the end of the number, we have 2 zeros. Let us see. Now, trailing zeros, when do they become significant? They are significant if there is a decimal point. Okay, and what if there is no decimal point? If there is no decimal point, they are not significant. So in this case, we don't have a If there is a decimal point, they are significant. And what if there is no decimal point? Then they are not significant. They are not significant if there is no decimal point. Which means in our number we don't have a decimal point, so what can I say? These two zeros, the last zeros, are not significant. So I'll say these two are not significant, right? So totally how many significants are there in our number? 4 significants. Totally there are 6 digits, but only 4 are significant. Okay, now let us see some other rules. For example, there is a number like 2.000200. Now what happens? These two zeros, the last zeros, they are significant now because there is a decimal point. Now how many significants are there? There are 6 in our number, right? Okay, let's see the next rule. Next rule is, suppose there is a number 0.00100 or 1.00100, such type of numbers. Then what to do? Let us see. So first, the zeros on the right side of decimal point, on the immediate right side of decimal point. Now they are significant or not? Let us see. Again, there are two conditions here. First one, if the total value of the number, if the total number is greater than 1, then those zeros are significant. So if it is less than 1, obviously they are not significant. So if the total value is less than 1, then they are not significant. So now let us bring the example numbers again. So out of these two numbers, in which one the zeros will be significant? Say in the first one, the total value is 0.00 something, which is less than 1, which means the zeros on the right side of decimal point are not significant. In the second one, it is total value is greater than 1, 1.00 something, greater than 1, or I can write another number, something like some 2.00100. This one also greater than 1. So in such cases, those zeros are significant, right? So I'll say here these are significant. The zeros are significant in these two, right? So this is about this one. Otherwise, you can do one thing. Actually, this rule is only for theory purpose, but when you practically do, you can see that according to second rule, these two zeros are, according to second rule, these two zeros are between two non-zero numbers 1 and 1, so they are significant, obviously. Okay, this rule is only for theory purpose, right? So what about next? Now if there are any zeros on the extreme left, zeros on extreme left of the number, never count them. They are not significant. For example, 00200. Okay, in this the left side zeros, these two are not significant at all. Two non-zero number significant. What about the right side zeros? They are trailing zeros. Second rule, trailing zeros, and there is no decimal point, so those two are not significant. So totally how many significants are there? Only 1, right? So these are the rules to identify the significant figures in a number. Easy. Now there is one special rule. One special rule is, suppose if you get a measurement directly, let us say I said there are 5 fingers in my hand, I said, or I have 2 hands, I say like this. Then I'm writing like this one, 5 fingers. How many significants are there in this? Actually, the number contains a single digit. But if you ask me how many significants are there, I'll say the number of significants are infinity. Why infinity? Because when I said 5, this is accurate value. There is no possibility of 4.99 or 5.01. No possibility. Directly it is 5. It's a direct measurement, accurate measurement, 100%. We know that. So when there is a measurement which is perfect, then we can say it is having infinite significance. But practically, when you measure length or mass of an object, we don't get the exact value. There may be some millimeter, some micrometer, nanometer difference. Hence, generally significance in practically measuring with some instruments, it need not be infinity. Okay, but when you measure the number of people in a family, number of fingers on the hand, so in these kind of measurements, it's a direct value, so the number of significance will be infinity. So these are the rules, right? Now by using this one, let's go to the next concept in this, that is rounding off. Okay, going back to our initial first number, 141 crore, 140 crore. There, what did we mention? 140 crore I wrote like this. In this one, I'm having some lakhs and thousands, but what did I do? I wrote a round figure there. Round figure 140 crore I told. This kind of approximation is called rounding off. So let us see what is this rounding off and what are the rules we follow for rounding off. Okay, let us see. Imagine you went to a restaurant and the bill is 499 rupees. So generally we say it is 500. You are rounding off to the nearest value, 500. If it is 401, then we say it is nearly 400. So rounding off, right? So what are the rules to round off the numbers? Let us see. First one. Suppose there is a, let's start with an example. There is a number like 2341. There are 4 digits, all are significant non-zero numbers. I asked you to write it in 2 significants only, round off. So it is 2341. We can say it is nearly 2300. This is rounding off, correct? But how do we do this? Let us see. Here, to do this one, we define 2 terms. One is uncertain digit and another is insignificant digit. Let us see what is the meaning of these two. Uncertain digit. Uncertain means the last one to retain, the last digit to retain. Meaning, see, we want in 2 significants, so second one is the last. So the last one to retain is 3. 3 becomes uncertain for me. Suppose you asked me round off to 1 significant only, then the first one is uncertain, then 2 will be uncertain, right? So whichever the digit you are rounding off, if you round off to 3 significants, I mean you want a final answer in 3 significants, then the third is uncertain. If you want final answer in 5 significants, then 5th digit is uncertain, like this. Okay, so in our question, I asked you to round off to 2 significants, so 3 will be uncertain, right? Then what is the insignificant? Simple. Insignificant is nothing but the number next to the uncertain. So in our example, 3 is uncertain, the next one is 4, that is insignificant. Okay, now how do these two help us to round off? Let us see the rules. So first of all, rounding off means we are removing the extra digits, keeping only certain number of digits, right? While rounding off, what we do? First rule. Let us see the first rule. Rule number 1. It is if the insignificant digit is greater than 5, insignificant greater than 5, then add 1 to the uncertain. Okay, what if it is less than 5? If the insignificant is less than 5, then leave the uncertain as it is, no change in the uncertain. So no change in the uncertain if the insignificant is less than 5. So let's take an example. Suppose if there is a number 2316, there are 4 significants in this. I want 2, rounding off to 2 significants. Then which is the uncertain? Uncertain is 3, insignificant is 1, and insignificant 1 is less than 5, right? Insignificant is less than 5. So what should I do? No change in the uncertain. So now the value becomes 2, 3 will not change, and the remaining removing 0, 0, right? But we have to remember one thing here. What if the number is like this, 2.316? Then again, rounding off, uncertain is 3, next one is less than 5, of course same. So 3 will not change, 2.3. Now don't write zeros. What happens if you write zeros? Now it is becoming 4 significants. Why? Because the trailing zeros are significant if there is a decimal point. Now you are writing 4 significants, but we want only 2. So what do? Remove these 2 zeros. Don't write them. So write only 2.3. So remember this. After removing the extra digits, if there is a decimal, completely remove them. If there is no decimal, replace them with zeros, like the first number, right? Okay, now second rule. Rule number 2. What if, now the insignificant less than 5, greater than 5 we discussed. What if it is equal to 5? If the insignificant is equal to 5, then the uncertain will decide what to do with the uncertain itself. Okay, now 2 conditions here. If the uncertain is even number, and if the uncertain is odd number. Let's see. So let's take a number. Let's take some example like 2, 3, 4, 2, 5. Another number 2, 3, 4, 1, 5. Now I asked you, each one is having 5 significance. I asked you, round off to 4 significance. Then what will you do? In the first value, in the first number, 2 is uncertain, 5 is insignificant, right? It is equal to 5. Now what to do? Uncertain, even or odd? It is even. Now if it is even, no change. If it is odd, add 1. So what will happen? In the first value, 2 is uncertain and even number. So after rounding off, it will become 2, 3, 4, 2, 0. 2 did not change. 5 is extra digit removed. Now we have 4 significance. What are we doing here? Rounding off to 4 significance. And now coming to the second value. Again, I asked you, round off to 4 significance. Then what do we do? Again, 1, 2, 3, 4. 1 is uncertain. Next number is greater than equal to 5. So, and it is odd number. So what is the rule? Add 1 to the uncertain. So 2, 3, 4, 1 plus 1, 2, and 5 is removed. 0, right? That is rounding off. Simple. So what are the rules? If the insignificant is greater than 5, we are adding 1 to the uncertain and removing the others. If the insignificant is less than 5, then we are leaving the uncertain like that and remaining extra digits are removed, right? When it is equal to 5, checking whether it is even or odd. Uncertain is even or odd. That's all. So it is very simple. Rounding off. That's it. So rounding off completed. Now what next? Insignificant figures. Calculation with significant figures. So we are doing either multiplication or addition something, then the result also will depend on how many significants are there in the data. Based on that, we have to round off the result. So for example, if you get 2.0 into 1.0000005 zeros, let us say, actual answer is 2.6 zeros will come. But according to significant rules, we cannot write like this. Okay, now let us see what are those rules and how should we write this. Let's see one by one. First rule. Simple. Always, before writing the first rule, I'll tell one common point to remember always. Whether you do addition or multiplication or anything, the main basic thing to remember is the result should not have more accuracy more than the data. Okay, the result should not be more precise than the data. So we're using two numbers with some precision, like 3 significants, 3 significants. The answer should have either 3 significants or less than that. It should not have more than the data. That means when the data has some accuracy, the result cannot be more accurate. When you multiply two numbers with some error, the result will definitely have much bigger error, not smaller error, right? So that is the main theme behind these rules. Okay, now let us start. First rule. While doing multiplication or division. Now observe the rule. Here the rule is the result, whatever the result we are getting, the result, like if it is multiplication it is a product, if it is division it's a quotient. The result should not have more significance than what? Should not have more significance than the least significance in the data. So in the data, let's check in the data how many numbers are given. In each number, how many significants are there. Now identify the least significance in them. The result should have same as that one. Okay, it can have less than also, but not more. That's it. Let's take an example. Let's assume that we are multiplying 1.0 into 2.000. Now observe the significance first. In the first number, there are 2 significants. In the second number, there are 4 significants. Correct? Now, answer should have 2 only. Okay. Actually, multiplication is 2 point. What will we get? 2.40 should come. But according to significant rule, we should have only 2 significants. So answer is 2.0. So this is actual multiplication and this is according to the significant rules. Correct? Now let's do one more. Let's say we are dividing 3.000 by 1.0, let us say. Now what should be the answer? Actually it is 3 and answer should have only 2 significance because the numerator is having 4 significance, denominator 2 significance, answer should have only 2 significance. So answer is how much? according to the significant rules, it is 3.0, right? So like this we can do. Similarly, without decimals also, let's try one question. Suppose 200 by 25. Actual answer is 8, right? So here we need not do anything. Already the data least one, 200 is having only one significant in it, 25 is having two significants in it, answer is having the least one significant equal to least significance in the data. Now we need not round off anything, it is already rounded off, right? Okay, so next let us do second rule for addition and subtraction. What to do? You are adding or subtracting two numbers. Now keep this in mind carefully. In this case, in addition subtraction, we don't care how many significants are there totally. We don't care. We care only about the decimals, the number of decimals. This is important in addition and subtraction. Always remember this. Number of decimals is important. Okay, now what is the rule? Simple. The result should not have more decimals, than the least decimals in the data. So in the data, for example, the least decimals are 2, then answer also should have only 2 decimals, not more. So what do we do? After finding the answer, subtraction or addition, then we will round off. We will round off such that the number of decimals is equal to same as least one in the data. For example, the numbers 1.00, let's add, plus 2.0000. The answer will be 3.0000, actual answer. But what is the significant rule telling? Observe the least significance, least decimals. So least decimals here, in the first one there are 2 least decimals, in the second one there are 4 decimals. So least is 2, answer should have only 2 decimals. So answer is 3.00. This is according to the significant rules, right? So these are the rules for significance. Now it is easy. Let's check some questions. First question. Identify the number of significants in 202. Let's do. First pause the video and try by your own, then come to the answer. Did you try? I hope you got the correct answer. Here there are 2 non-zero numbers and 1 0 is between the non-zero. So according to first rule, 2 and 2 are significant. According to second rule, 0 is also significant. So there are 3 significants totally. Now tell me this. 2.01 into 10 power 5. How many significants are there? Remember, in such cases, what we do is just check the number only. This 10 power 5 is called order of the number. Suppose if I say 500, it is 5 into 10 power 2. 10 power 2, 2 is the order of the number, whereas 5 is the actual number. So here we see only the number but not the order. We don't care. It may be 10 power 7 or 10 power 10, 10 power 1000. Don't care. The number has 3 significants, 2 and 1 non-zero numbers and 0 between the non-zero numbers, right? So totally there are 3 significants here. That's all, right? Let's try one more question. Try this one. This will be interesting. 999. Round off to 2 significants. Let's say first of all round off to 1 significant. Round off to 1 significant. So what will we write? Here let's follow the rules. It is easy, but let's go according to the rules. So to one significant mean, then the first one will be uncertain. So the second one is insignificant. Now the insignificant value 9 is greater than 5. So we'll add 1 to the first number. So it becomes 10 and the remaining 2 become 0. So 1000. And it is having only one significant. Trailing zeros are not significant, right? So this is the answer. Now the question is, round off the same number. Let's take question number 4. Round off the same 999 to 2 significants. Now pause the video and try the answer. What are you getting? Are you getting 1000 according to the rules? Then it is having only one significant. We need 2. So what to do? In this case, first of all, convert into scientific form, right? If you convert into scientific form, then we will get proper values. Okay, one method is 999. You can write it as 1000 after rounding up. First one is uncertain and the next digit 9. Second one insignificant is greater than 5. So we will add 1 to the uncertain. It becomes 10 and remaining 2 became 0, 0. It is having only one significant. Now convert into scientific notation. What is scientific notation? Any number can be written as something something point something into 10 power something. I mean, you can write any numbers here. Before the decimal there should be one digit. So for example, 5.2 into 10 power 1. Actually it is equal to 52. 52 is general notation. 5.2 into 10 power 1 is scientific notation. So I can write 1.4 into 10 power 3. What does this mean? It is 1400. This is the scientific notation of writing that. Putting only one digit before the decimal point and writing as 10 power something. Now let us write the given our answer as scientific notation. So what do we get? This can be written as 1.000 into 10 power 3. Okay, we converted to scientific notation. Still it is not completed. Now we have to round off to 2 significants. So what do we do? It is written as 1.0 into 10 power 3. Now we have only 2 significants here, 1 and 0. 0 is significant because there is a decimal point. And 10 power 3 we don't care, that is just the order. There is nothing to do with significance in the 10 power 3. So that's it. So these are the rules. So whenever these kind of numbers come, if you convert to scientific form, it is easy to do. In fact, actually what I do personally is, whatever the number you give, first I'll convert to scientific form, then I will do the round off. Then there is no confusion at all. Okay, so you can follow like that, or you can just round off normal numbers, and when these kind of numbers come, you can round off to scientific notation and do it. So this is all about significant figures and their applications. I hope you learned something today. If you did, please share it to your friends. Maybe it will help them, maybe. So if you feel it will help, you can share to other friends, and have a nice day. Learn the basics carefully, then the subject will become easy. Hold the basics, own the subject. All the best. Jai Hind.